All right, so our last kind of challenge example here is what do we do if we're working with negative exponents? So let's say we start off with 1 over 5 to the x power equals 25 to the 6x power. So again, we don't have like bases, so let's break down our 25. That's going to get us 5 times 5, or 5 squared. And that, to be honest, doesn't really solve our problem here, because now we have 1 over 5 to the x, which equals 5 squared to the 6x. And those things still aren't the same. So what is something that we can do? How can we basically go through and fix this? Well, 2 wrongs don't make a right, but 2 negatives do make a positive. So we can go ahead and kind of use that idea to go through here and actually fix this. So if we take our bottom, our 1 over 5 here, what we're going to want to do is basically, what do we need to do to get this to 5 to the something power? What do we need to do to our base? So we can take our bottom, and we can rearrange this a little bit here. So we can rewrite this as 5 to the negative 1 power. And again, remember that these are the same thing. 5 to the negative 1, by definition, equals 1 over 5 to the first power. So that allows us to do this. 5 to the negative 1 times x. So now we can rewrite this as 5 to the negative 1 times x, or 5 to the negative x power. So we used our definition there, and it allowed us to bring our 5 back up to a way that we know what to do with it. So again, we're going to take this, and we're actually going to be able to replace that with that. So let's rewrite what we have here. So 5 to the negative x equals 5 to the 12x. And again, we distribute here, we multiply those two. So now we can go through and we can solve this. So negative x equals 12x. Can add x to both sides. That leaves us with nothing over here, and that leaves us with 13x over here. Divide 0 by 13, and we get x equals 0. So as always, a good idea to go back and check your answers for these things to make sure that what we did just made sense. So go back up to our original question here. 1 over 5, and we'll do it in the corner here, to the 0 power equals 25 to the 6 times 0 power. So 1 over 5 to the 0, you can punch it into your calculator, or remember the definition that anything to the 0 equals 1. Then on the other side here, 6 times 0 is 0, so 25 to the 0 actually also equals 1. So our solution in this case works. The big takeaway from this is that we can take something like 1 over 5 and change it to 5 to the negative first power to make our bases equal. It's a little bit of kind of playing around with our operations there, but that lets us go through and do what we need to do. One more example for this, because it is a bit of a challenge skill. Let's say that we have 1 over 6 to the x plus 2 power equals 6 to the, let's say 2x power. So in this case, we can change 1 over 6 to 6 to the negative 1. By definition, x plus 2 equals 6 to the 2x. Distribute that negative 1, so we have 6 to the negative x minus 2 power equals 6 to the 2x. And then now, just like before, we can go through and solve using our exponents. So add x to both sides, we get negative 2 equals 3x. Divide both sides by 3, and we get x equals negative 2 over 3. So again, using our properties, we can switch between our forms, our 1 over 6 to 6 to the negative first power. All right, everybody, as always, questions reach out. That's the end of this assignment, so make sure you complete those questions. Use those hints